So large language models, we're using them in our developer tools, and I've been really excited about the way that they make me more productive as a developer. But they've also had me being a little curious, like how do they change the way that we build applications? They have this great ability to understand what it is our users are saying to them. And so how can we use that to improve the user experience of those apps? And this idea is starting to emerge in a lot of different ways, and it's called generative user interfaces. Generative user interfaces. Generative user interfaces? One second, let's see. So generative user interfaces is this idea that we're going to take large language models and we're going to simplify a variety of use cases in our application. It is fully mirrored, so I don't know why my slides are not appearing if I could get a little bit of help from someone.
Someone is coming already.
Fantastic. 1 second, please.
Okay. What did happen when you...
It worked fine.
Okay.
We're just going to start the whole thing over as soon as we get this fixed. We're going to roll it back from the top. It's always a spell to cast. Hey, we got slides. Great. Thank you so much. Okay. So generative user interfaces is this idea that we're going to use large language models to improve the accessibility, usability, and friendliness of the applications that we're building. Let me give you kind of an abstract example, and I'm going to spend the rest of my time just showing you real code and real examples of this in action. So let's imagine that our applications kind of start with this home page where our users come into our app. And from there, they're trying to get to various features to access our system. Those features themselves have a variety of subpages that allow them to configure, interact with forms, and make changes. And we kind of lay this out in a way that allows users to navigate around these applications, right? They can get from one page to the other by clicking through navigation links, using our routers to get from page to page to page. Well, with generative user interfaces, the idea is that we want to simplify the way that these component trees are laid out. For example, we're going to take complex forms and we're going to simplify them by accepting our users' natural language, creating softer, simpler forms. Additionally, we're going to give users the ability to generate shortcuts that move them from one part of our application to the other to speed up the workflows that they're working on. We're even going to do things where we're going to eliminate entire trees from our application and replace them with pages that can self-organize, that can even write the code that they need to produce the results that our users are hoping for. And so with generative user interfaces, what we're doing is we're threading AI throughout our application, again, to improve the UX. And to do this, we've created an open source framework called Hashbrown. Hashbrown is a framework for building AI native components in both React and Angular. But first, let me introduce myself. My name is Mike Ryan. I'm the tech lead for Hashbrown. I'm also a GDE in Angular, and I'm a principal architect at Live Love App, where we help companies bring data to life on the web. So here's how Hashbrown works. You first bring in a Hashbrown adapter package into your backend. And it's going to harvest intelligence from the AI provider of your choice, whether that be OpenAI, Azure, Gemini, or even open weight models via Ollama. From there, it's going to form hardened streaming responses that allow your web application to consume AI responses. Hashbrown gives you, the application developer, access to AI state management, tool calling, and even a JavaScript runtime to build generative UIs. So let's just kick it off with a bunch of examples. The first one I'm going to show you is completions. So I have a web application here, and it's kind of a smart home app. These are the lights that are in my apartment, and I have scenes that can control these lights. And the first thing I want to show you is this idea of doing tab to complete. We are already used to this in our IDEs, where when I go to write code, I get suggestions from my AI that I can hit tab to accept on and kind of move myself through code changes fairly quickly. But for our users, let's say that they're trying to do some data entry tasks. So as you see here, I have some ambient lights in my living room. Well, if I were configuring more of these, wouldn't it be great if our inputs actually had the same kind of tab to complete experiences as our IDEs? So let's kind of see how some of this code works. Well, it starts off with a completion resource. Hashbrown is leveraging the new resources API. Even though it's experimental, we think this is the right primitive for consuming AI completions inside of your application. With the completion resource, the first thing you do is you specify the model ID depending on the provider you're using. In this demo, I'm going to be using models from OpenAI, in particular GPT 4.1, but as I mentioned, it works really great with a variety of providers, including Google's Gemini models, and models from Writer, and open weight models via Ollama. Once you've specified your model, you then specify a system instruction. This system instruction is basically the prompt. It guides the AI on the task that it's trying to achieve. So here, we're telling the AI that you're trying to help the user predict or come up with a new light name. You're going to be given the current input, whatever the user has typed in, along with the existing names that have already been chosen. Output only the next text segment to append, no extra words or explanations. And from there, it's all signal-based as well. So we're going to give it the input that it needs to generate this completion. I'm going to use, first off, the value of what the user has typed into the input up to this point. I'm also going to give it the list of existing names that it's going to be able to look at to determine, okay, are there patterns that I can follow, or are there names that have already been taken that I can consider when I'm generating my completion? I'm using Computed to bundle this up into the data that I'm going to provide to the large language model as it generates this completion for me. But like generating text and tab to complete, that's kind of the simple thing. So let's build on top of that. Because with Hashbrown, you can actually generate structured data from large language models. So let's say I want to go create a new scene, and I want it to adjust my living room lights and dim them to, say, 30%. Well, in a traditional form workflow, I could go through and I could select each individual light and kind of get the slider in the right spot. And that would work great. But if we have the ability to understand natural language and derive structured data from it, then I can instead say dim living room to 30% and use the LLM to try and predict what lights that the user might be trying to select. So you can see here from the name alone, it's chosen all the lights that it thinks are in the living room, and it's suggesting to set them to 30% just based on that name. So how does this work? Well, just as I showed you the completion resource, Hashbrown also comes with a structured completion resource for getting structured data out of a large language model. It starts the same way. You pick a model, again, in this case, I'm using GPT 4.1, and you give it a system instruction. Hey, help the user pick the lights based on the name they've entered so far. We're also going to give it the input data. This is still the same as we've seen before. But what's going to be different with a structured completion resource is you're going to give it schema that describes the kind of data you want the LLM to generate. And this schema is written in a schema language that comes built into Hashbrown called Skillet. And Skillet is an LLM-optimized schema language. What that means is, first off, it gives you strict type safety. So just as you'd come to expect from any other schema language like Zod, as you write schema in Skillet, you're going to get really great TypeScript types back out of it. It's also highly descriptive. So in a lot of schema languages, the description field is optional. But when you're using large language models, context is king. And so Skillet puts the description first. You have to provide a description as you're modeling your data with Skillet. That way the LLM can make the best understanding of what that data is. It also generates really clear error messages. Well, that's great for us as developers, but it's also really important for large language models. It allows them to self-heal so that if they generate bad data that doesn't conform to the schema, we can create a really good error message, give it back to the LLM, and let it correct itself to produce data that does comply to the schema. But my favorite feature of Skillet is that it actually comes with a streaming JSON parser built in. So if I go back to this demo and switch this to 50%, notice that it takes a little bit of time for those suggestions to come in. The LLM is kind of processing it and then generating all the JSON that's required for it to show these suggestions. But with Skillet, if I go into the code, here's the actual prediction resource that's doing this. I can go down to that schema, and anywhere that you have an array, an object, or a string, you can simply type in the streaming keyword. What this will do is it's going to tell Skillet that as the LLM is producing JSON and streaming it into our web application, eagerly parse items inside of this array as they conform to the inner schema of the array. So now that I've added that streaming keyword, I can go back in, add a scene, dim living room to 30%. And now we'll actually see those suggestions stream in as fast as the LLM is generating the tokens and getting them into our web application. And we can use this for a variety of use cases. Like doing these suggestions is really cool, but I really am excited about the ability to simplify complex form controls. I've had the displeasure of building this kind of UI where you're essentially setting up a recurrence for an event. So this is Google Calendar. This is the way they do it. If I were scheduling an event, I could say, okay, it repeats daily or weekly, or I can even go into this custom flow where I can pick the type of recurrence and really customize every detail of how this is meant to play out. And having built this, this takes a tremendous amount of time to actually build correctly. And getting it to be both internationalized and accessible for screen readers can be a real chore or labor. But with large language models, we can understand user language. So when should this scene run? Well, it should run every other Tuesday, starting next week. And what it's going to do is it's going to parse that and actually generate a valid R rule, if you're familiar with the iCalendar specification. It's taken this natural language and actually produced an R rule. It knows that it's weekly. It knows that I'm in the LA time zone. You can see my laptop thinks it's 14 a.m. It shows in a start time. It shows in an interval of 2, because it's every other Tuesday. And then in the by day, we can see that it's chosen Tuesday. What's really great about this is it handles kind of fuzzy inputs. So if I type in something that's completely nonsensical, like 10 bananas, that's a lot of fruit, but it's not a valid recurrence rule, we can see that we can get really good error messages out of the LLM. It says, this doesn't contain a recognizable date or recurrence pattern. Okay, well, what about sometime next week? Well, that's not specific enough either, right? This description is too vague. Please clarify the date and time. And it's not until I actually clarify that date and time that it starts to work. We're going to swap out my mic. So now we can do something like every Saturday at 6 a.m. until December 31. And again, it's parsed this out. It's chosen the right start time. It's given me an until statement until December 31st. It's chosen the minute and hour based on what I've typed into it. This is a lot more accessible, right? It's not a huge tree of components and navigation elements that someone with a screen reader would have to get through in order to configure this. But it's also really internationalized. I'm getting married in 2 weeks, and my soon-to-be wife, her native language is Marathi. And so I've been trying to learn Marathi as I've been in this relationship with her, and ChatGPT has honestly been a really wonderful resource. So I've used ChatGPT to come up with a Marathi translation of every other Tuesday, starting on December 28th. I'm just going to copy this into my application. And with no additional effort on my part, it understands this language and also produces a valid R rule definition, and it's exactly correct. It's on September 28th. It shows every other Tuesday. The interval is 2, and we can see that Tuesday was pulled out of it. And so with LLMs, I've created a form input that is both more accessible and internationalized. But let's keep building on top of this idea a little bit more. Because one of the things that we can do is we can create predictions that help move our users around the application. So if I went back here and I created that light from before, living room, ambient light 3, and hit add, well, I'd have to go change all of these scenes and reconfigure them to add this new light to the application. But using an LLM, I can instead look at that user action and I can create suggestions that help speed the user through what workflows they're currently working on. So it knows that the user has just created this new light, and it says, hey, you probably want to add these to these scenes with these various brightness levels, because that's what I think you want to do. And as a user, I can either hit dismiss if it makes no sense and kind of keep focusing on what I'm trying to get done. But if it does work, I can hit accept and get through this workflow a lot quicker. I'm just going to quickly delete my site data. That way, that doesn't trip me up later. So predictions and suggestions, that gets us part of the way there. But what if we want to let LLMs take action on behalf of our users? Well, with Hashbrown, we can actually connect our Angular service layer to LLMs with something called tools. What this lets me do is I've got a chat experience here on the right, and I can ask a question like, what are the lights in the living room? And what this is going to do is it's going to run a tool called getLights, and you can see it responded back to the user letting it know that there are lights in the living room, and it chose the 3 lights that exist there. I'm going to say something like, turn them off. And because this is using my Angular service layer, when it runs this, we're going to actually be able to see it change in our user interface in real time as it performs that action. So it ran that control light tool 3 times and turned off all 3 of those lights. So the way this works is in Hashbrown, you have a helper called create tool. And this lets you create tools that you can feed into large language models. To create one, first you call that create tool function, and then you provide it a snake case or camel case name, along with a description of what exactly this tool does. And using Skillet, you can actually have the LLM generate structured data as an input to your tool. So in order to control a light, I would need both the ID of the light that it wants to control, along with the brightness of the light that it wants to set it to. Once you describe the schema for it, then you write a handler function that takes that as an input. And this is just Angular from this point forward. It's running in an injection context. I can inject any Angular service I want to. I can call it, and then whatever that service call produces, I can feed it back into the LLM to let it continue to do its work. Once I have my tools created, then I can drop it into any of Hashbrown's resources. So the completion resource and the structure completion resource take tools, but so does a chat resource. So if you want to create a more conversational UI, you can use the chat resource to do it. You call the chat resource, you give it the ID of the model you want to use, along with the system instruction that should apply as you do it, and then you can just drop in all of the tools that you want the LLM to have access to as your user is conversing with the agent. But I want to go even further than that. Building on top of each of these concepts, what if we took everything that we've seen from Skillet to tool calling and actually let the LLM generate not just text, but generate full user interfaces? So I was kind of cheating earlier. This wasn't a chat resource before. This was actually a UI chat resource. And what a UI chat resource is it's a chat resource where the large language model is not streaming text back, but it's actually streaming user interfaces back to our web application. So it's the same thing we've seen before, a model and a system instruction, but what I have here is the components that it's allowed to use to form these responses. Right now, I've only given it access to a markdown component, and you can see here that I've given it the class, the actual Angular component, to this exposed component function, along with a description of what this component does. Then I can specify Skillet schema for any of the inputs of this component, and the LLM, when it chooses to use this component, will actually generate data that gets bound to these inputs. So the markdown component needs to have the data to it. This is actually just the markdown component from NGX Markdown, so thank you to the open source authors behind that. And I can use that same streaming keyword to stream data into it. So as it's generating markdown, we can render it in real time by streaming that into that data. But what if I wanted to do some more components? Well, let me go ahead and uncomment this next one here. This is a light list component. It shows a list of lights to the user. And any of these can actually have children. So children can be any, if you want to let the LLM choose any component to be its child. It could be text, if I wanted to let it render text into it. Or you can give it an explicit list of components that are allowed to be rendered as children here. So here I've given it a light card, which is going to show a light to the user. And I instruct the LLM that you should always prefer this option over printing a light's name. Just always show them a card and bind to it the ID of the light that you want to show. I'll do the same thing for the scene button. So if we want to have it render scene buttons, we can do that too. It also has access to a get lights tool, a get scenes tool, control light, and apply scene. So now I can say what scenes and lights are in the living room. And again, this would work with any language that the LLM could understand. I'm going to type that in. It's going to call those tools, and then it streams an Angular user interface right in back to the user using those components that I've given to it. And it's using the components, it can only use the components that I've given it access to. It is limited. As a developer, I have control over what UIs it's allowed to generate. And these are real Angular components. Like I can go interact with them, I can scrub them to change them. These are connected to my service layer. Like this is fully an Angular component that has been rendered back as a result of the LLM choosing to do so. The final thing that I want to show you is perhaps the most harebrained part of Hashbrown. We've been wondering, as we've seen today, these LLMs are actually getting pretty good at generating code. We're using them daily in our developer tools because they're getting better and better at assisting us in that code generation. So we were kind of thinking like, what if we could generate code on the fly in response to what our user's trying to do or application context, and then actually run that code? And so what we did is we took Quick.js, a C-based JavaScript runtime, and we compiled it to WebAssembly and shipped it as part of Hashbrown. And you, as the Angular developer, can create JavaScript runtimes and expose Angular services into that runtime. By default, that runtime can't do anything. It doesn't have network access, it doesn't have access to the DOM. It's a fully isolated container that lets you safely run untrusted code, and LLM code is definitely untrusted code. So let's take a look at an application that leverages this. This is another sample app. This one lets us kind of query about ingredient consumption inside of a Waffle House, which is a famous breakfast restaurant back in the States. So let's go ahead and say, what is the total cost by category over the last 12 months? And what I've done in this application is I've actually created an agent that knows how to write code to render a chart in response to this. I'll show you the full code in a second. You can see here that it's currently writing it, and it's generating that code in response to this. And what it's going to do is it's going to call my Angular service layer to get all of that data. And then once it's gotten it, it's going to combine it in the way that it needs to. And then it's going to call a render chart function that actually renders a chart based on it. And what's great about this is I am in control again. I'm the one who has chosen to write this coding agent and described its total behavior. So we can see we've had some success. It's rendered a really nice bar chart for us with all the categories over the last month, and I can kind of introspect or see those total costs. But what's really nice about this is, well, let's go ahead and dive into some code first. So with Hashbrown's JavaScript runtime, the way you create one is you call this create runtime function. This is going to load the WebAssembly into your application and sort of get everything wired up so that you can expose functions into that runtime. Exposing functions is fairly similar to setting up tools. So here I'm creating a runtime function called getData. And what this does is it's going to get the data for the chart. It takes both an arg schema and a result schema. One of the ways that Skillet is LLM optimized is that it isn't just capable of generating, say, the JSON schema for structured outputs, but it can actually generate TypeScript definitions from the schema you described. So using both the name of the function, the arg that takes in, and the result schema, we actually print a full TypeScript type definition for the LLM. That way it understands how to call this function and the data that it's going to get back from it. From there, you just give it an async handler, and at this point, it's just Angular again. I'm back in an injection context. I can inject my ingredients service. I can call it using those arguments. I'm going to use last value from to turn this observable into a promise and return that data back to the script. One of the optimizations that we've made here is we're using something called the asyncify transform in Quick.js. What that means is that the functions that we write and expose inside of this runtime can be asynchronous, right? I'm using the async keyword. But if I go back to the script that it actually wrote to generate this and look for the call where it actually called getData, you'll notice that it didn't use await in front of it. You see, if we were to try to make the LLM write like asynchronous control flow logic, I'm telling you that the script quality gets a little worse. It sometimes gets tripped up on those promises. And so inside of the runtime, even though these functions were implemented asynchronously, we actually pause execution and let that fully resolve before continuing the script. That way the LLM only has to write really simple, procedural, synchronous code. And so it got the data, it made an assertion about it just in case there was no data around, it bucketized them based on that category, and then it sorted those categories out, it chose some nice colors, and then it called render chart. So render chart is even simpler of a function. If I look at it, it's called render chart, and it takes in this huge chart schema. And all I'm doing is I'm just capturing those args and setting it on a signal. That way my canvas or my chart.js component can just read that schema out and render that chart. And so because all of this schema happens to be a part of the script, as the user, I have the ability to target that when I prompt it in my UI. So for example, I'm going to say, rename this to total cost, put the title at the bottom, and make it look like it came from 1990s Excel. Because all of that is part of that script that it wrote, it's going to be able to take that and actually modify the script in response to it. So now it's rewriting that JavaScript. It's going to keep all that same logic, but as you see, it successfully changed that chart. It chose colors that are maybe a little bit more reminiscent of a different decade. It put the title at the bottom, and it had full success. And what's really great about this is it can do more than bar charts. We could switch this to pie charts. It handles line charts, compound charts, multi-axis. It has the full schema from Chart.js. And so you can use Hashbrown's JavaScript runtime to generate glue code between your service layer and your component layer when it makes sense to do so. So what's the idea with Hashbrown? The idea with Hashbrown is that we're going to take our user interfaces and we're going to thread AI through it, writing AI native components. The best part is that it's 100% free and open source. It's MIT licensed, and everything that I've shown you today, you can go check it out on GitHub. We'd love to have you contribute to the project. We think this is a really exciting space, and we're excited to see how it continues to evolve over time. And you'll probably see a few familiar faces in our list of contributors. If you want to learn more, you can check out hashbrown.dev. We have tons of recipes that guide you on how to build some of the features that I've shown you, along with a lot of starter code to get you started. We also teach workshops. So if you've never used an AI SDK before and you want to get into the deep details of how to build generative UIs, please check those out. We'd love to have you there. Before I get off stage, I just kind of want to end with this idea that, we want to use large language models to build apps that are conversational, easier to use, and more accessible. The idea here isn't that we're replacing engineers or trying to automate the creation of UI or anything that I would consider to be maybe harmful. Instead, what I'm trying to do is I'm trying to use a large language model to build apps that shorten the distance between what my user wants to do and what my system is capable of doing. It accepts their natural language and can converse back with them to help them accomplish their tasks. It's easier to use because we're stripping away components or complex logic. We're not asking them to find out how to navigate around our complex tree. They can ask questions and UI gets generated in response. And potentially, these apps are more accessible too. Because we've eliminated so much of that complexity, we can build UIs that are easier for people with impairment to get around. So with that, thank you so much, and I can't wait to see what you're going to cook up with Hashbrown. Thanks.